Dear student, in this video I am going to start a very important topic and very demanding, the turning effect of force. This is also called moment of force. You know what is the force? Force is a pull or push. This is what you have learned. It means when you apply the force to any object, in the form of either it will you're applying with pulling or pushing, and then you will see the further it will change in the shape, the speed is decreasing, increasing, or stop. There is one more effect called turning effect of force. Okay, this is also called torque. Now before that, let me start with the question that when you open the door, here what happened? You're applying the force at the door knob, right, which is here. Now the door is turning to which point? To the hinge. What is hinge? It is a metal part which is connected to the door and this supportive part which is here. So this door turn to this hinge. Okay, this hinge is also called, you can say, it's a pivot point. Okay, pivot point is a point where something turn. Now every knob is here. We never put the door knob here. Okay, you imagine that if the knob is here, it is very difficult to open the door, isn't it? So basically this is called a turning effect of the force. So here the turning effect means how the door will turn at the hinge depends on the two parts. The first, the magnitude of pull on the door, like how much you're pushing, the force applied, and second, the perpendicular distance of pull from the hinge. So this is your pull, you are pulling this direction, and this is the hinge. So how much distance it is there? As you can see here, if you compare the distance, it is a more, right? So d1 is more than d2. That's why I can say that it is easy to pull. The turning effect will be more. So can I say that moment of force, this is also called torque, is a product of force and the perpendicular distance from the pivot point to the line of action of the force. Let's just start with simple diagram. So this is the pivot point, okay, by which the door is opening, and this is the force, where you are applying the force. So this is the line of action of force. Force, suppose you can apply here, anywhere. So if you draw some line, this is the only perpendicular distance you will have, isn't it? So basically you should write this formula, that moment of force is equal to force multiplied by d. What is d here? Very important, write it down here. It is the perpendicular distance. Okay, distance from pivot point. And if I want to know SI unit, okay, you will forget definitely. So how to remember that? If I am writing moment is m, force will be Newton multiplied by meter. So the SI unit will be just Newton meter. Always pay attention, if the force is given in the Newton, the data in centimeter, better to convert in the meter because you are going to write the Newton meter. You can also write your answer in Newton centimeter, but you have to write it over there that the data is in Newton centimeter. Okay, so you have to pay attention. Now whenever the turning happen, there is a two condition, that if you apply the force this side, as you can see here, what happened, it will go to this side, means it will move anti-clockwise direction. When the force is applied downward, it will move in the clockwise direction, because this is turning can be anti-clockwise or clockwise, so depends how the force is applied basically. Now let's see some of the example. Okay, so question is that a student conduct experiment on the turning effect of force as shown in this figure. If the weight W is placed 15 centimeter mark as shown, determine the moment about the 40 centimeter mark. Okay, where half meter rule is held here. So this is the half meter rule. Half meter rule means 50 centimeter. Okay, now here you have to figure out which is the pivot point you have, means at which point it is moving. Okay, so they are saying that if the weight W is placed, where the W is placed here is your weight as 15 centimeter mark, determine the moment about the 40 centimeter cube, means this is your pivot point, because they are asking from this distance how much it is turning. So this is your pivot point. It means, let me solve it. So your moment will be your what? Force into perpendicular distance. I'm writing just d here. Now what is the d you have? So this is 40, this is the 15. So I have to figure out this d, which is around or 40 centimeter minus 15 centimeter, which will be, if you solve this, will be how much? 25 centimeter. You can convert in meter, 0.25 meter. Why I have solved this? Because perpendicular distance is your d, and this is half rule meter. So this is 50, 40, this is 50 mark. So this distance will be only 25 centimeter. Okay, so now you have to just multiply with the force. So force, they have already given you weight, which is the 5 Newton, multiply by 0.25, which will be 1.25 Newton. And what will the direction? Since the force will be, it's a downward, you will try to move in the clockwise direction. So it will be the clockwise direction. You should always write the direction because it is a vector quantity. If you just leave the answer without putting the direction, it is wrong or the marks will cut. Okay, now let's see question number B. So this was your A. The weight is then shifted to 5 centimeter mark as a result. So now this weight I have shifted to the 5 centimeter mark. So this is 0, and it will be 1, 2, 3, 4. Suppose this side, right? You have shifted to this side. Now, as a result, the student feels that it is more difficult to maintain the half meter rule in horizontal position. Compare and why. So basically what you have did, you have moved to this side. So now the moment is equal to force into d. Okay, so what will your d now? You have to figure out d will be, if you have moved to the 5 centimeter here. So total distance from here to here, how much? It will be your 40 minus 5. 40 minus 5 centimeter, which is the 35 centimeter. If you convert in meter, it will be 0.35 meter. So this is the distance. Distance is always very important. If this calculation will be wrong, your other data will be wrong. Now if I have moved to the further away, the turning effect will be more, means now it will turn more than the previous. So what is the turning effect now you have? 5 Newton multiplied by 0.35. So let's solve it. If you solve this, you will get 1.75 Newton. What is the direction? Obviously you have not changed the direction, so it again will be clockwise. So it will be again clockwise. So if you look and compare from A, it was here 1.25 and here 1.75. So obviously this is bigger. So when you have moved the weight to the 5 centimeter, it's basically the more distance from the pivot point, so the turning effect will be more, right? So he will feel the lots of force acting on this side. So that's why it will more difficult to maintain the half meter rule. I hope this question is clear now. So in next video I will talk about the principle of moment. Please let me know how was this video. It will keep motivated me and will make more video for you. So I'll make principle of moment in just next video, because shorter the video, it's good to edit and also watch it. Thank you.